So what we want to do today is jump into the math for calculating density. So welcome to your lesson on calculating density. Density, as we mentioned earlier, is how much of that matter, how many particles of that particular type of matter are able to fit into a particular place. So it is the quantity of matter, how much matter there is. So the quantity of matter, or how much matter there is in a certain amount of space. And so because of that, we're going to measure it with the amount of mass, represented by m, compared to the volume, how much space it takes up. Now, before we dive too deep into it, we're going to have to make sure that you understand how density actually plays out in real life. So you can see as I'm reading here, solids are more dense. So this, you can see they're tightly packed together on the left-hand side there. Then you get the liquid state where they're a little looser, a little more space in between them. They can slide past each other. And as soon as they become less dense like a liquid, they have less attraction between those different particles, so they don't stick together quite as well. And then with the gas state, you're going to have very much so spread out particles. They're not very well attracted to each other, so they're able to move farther and farther apart. So solids, liquids, and gases are the most dramatic way that we can demonstrate density. But you can, even within all the solids, you can still have different amounts of density. In between liquids, you can have different amounts of density, okay? Just depends on how tightly packed the particles are. And the idea of how dense something is one of those physical properties that we talked about earlier. Before we get too far into the note, I want to make sure that you know some important conversions. So let me just write those down for you. So you've got 1 milliliter, that's a liquid measurement, is equal to 1 centimeter cubed. Now again, what's a centimeter cube? Well, it's if you were to make a little cube, and make sure that it's an actual cube, so all the sides are the same length and everything, you would have a centimeter here in this direction. You'd have a centimeter deep, and then you would have it a centimeter high. So if you can imagine a cube that looks like that, that's 1 centimeter cubed. And inside that cube, you could fill it up with 1 milliliter worth of volume. Okay, so they're both volume measurements, whether it's a cube, a solid cube, or whether it's a liquid milliliter. Okay. The next measurement that's going to be important is that you can fit 1,000 liters in 1 cubic meter. So that would now be a box that is a meter wide by a meter deep by a meter high. It's actually quite a big box. If you were to take from the middle of your chest out to the end of your fingers, if you put your arm out straight, that's about 3 feet, which is about a meter. So imagine a box that is that big. Maybe even if you're a little bit shorter, maybe it's from your left shoulder right to the tips of your right hand or something like that. Okay. And then the last conversion that's going to be important for you to remember is that every 100 centimeters, you have 1 meter. Okay. If you don't already know those conversions, memorize them now. The other thing that you're going to need to know is that we have to, when we're showing our work here, you have to make sure that you are showing all of the stages for your solution. So this right here, the format requirements are really, really, really important. This is how you're going to get your marks for these particular questions. So let's run through a question and I'll show you where that format kind of plays out. So here we have our first example. We're going to do the math here. And we are asked to find the density of a piece of metal. So that's how many particles are in a certain space. And then we know for sure, we've already measured it on a scale. We know that that piece of metal is 70 grams and that the volume is 9 centimeters cubed. So when we go back up and we take a look at our formula, we can see we've got here D for density. Then you've got M for mass and V for volume. So those are the letters that we want to use to represent our numbers. So we have D, little m, capital V. What is the density? Well, that's actually our unknown. We don't know what the density is. That's what we're being asked to find. We know that the mass is the 70 grams. And we know that the volume is 9 centimeters cubed. So for your first mark, where it says number 1, given info with units, you want to make sure that you write this all out neatly on the side. So I'm going to say that the density is my question mark. That tells me what pathway I need to be headed on. It'll show me which formula I'm going to need to use. Then we say that the mass is equal to 70 grams. And we say that the volume is equal to 9 centimeters cubed. So far, so good. You've got 1 mark out of 4. Next thing you want to do is use the equation. So we scroll back up and we see what the equation is. So it's D equals M divided by V. D equals M divided by V. And I write it out just like that. Now, because it's the density that I'm looking for, I'm able to, right away, I know that this formula is already set up and it's ready for me to use. So what you have here now on the left, you've got your number 1, given info with units. 2, you've got your equation. 3, we're going to do our substitution step. And that's just putting in what we know. We don't know a value for capital D, so we leave it as capital D. We do know the value for M, so we write it in. And we do know the value for V, it's 9 centimeters cubed, so we write that one in. And now we're ready to just do the math. So already you have 75% of your mark because you've got 1, 2, and 3 done. And now all you have to do is find the solution. So I'm going to grab my calculator. Now, what do I do with these units? 7.8 what? What we have here right now, 70 divided by 9 gave us the 7.8, but the G for grams is also being divided by the centimeters cubed, so that ends up being our unit. It's grams per centimeter cubed. That per just means that's a divide line. So here's how you're getting your marks. You have to have the given, there's your first mark. Second mark was from giving me the equation. The third mark was the substitution step. And the fourth mark was your final answer or your solution with units. Okay? So there's 1, 2, 3, 4. And if you can do all 4 of those parts, you're going to get 100%. If you miss, all you do is you give me the solution, you will only get 1 mark. Even if you have the 7.8 and it's perfect and you even have grams per centimeter cubed, you're only going to get 1 mark. You have to show me how you found the answer. So please make sure that you're always using this exact format. Okay? We call this format the guess format. You can see the word guess up here. We call it the guess format because it's given with units, the equation, the substitution, and the solution spells guess. So when I write on your work and I say, make sure you are using the guess format, that's what I mean. So now we're looking at a new question. What do they want? Well, they said find the mass. Okay, so that's M is the question mark. We're told that it's some object. We don't know what the object is, but we know that the volume is 12 and the density is 8.4 grams per centimeter cubed. So you want a mark? Then you better do this. Write out your givens. So the M equals, well, I don't know what the M equals. It's still a given piece of information, but I have to fill in the blanks there later. Then I know that the volume is equal to 12 centimeters cubed, and the density is equal to 8.4 grams per centimeter cubed. So in other words, if I had a cube worth of this material, and I put that cube onto the scale, I could measure it and it would weigh 8.4 grams. Here's the problem. Our formula looks like this, but I don't want to find density. I know what the density is. I want to find the mass. So what I'm going to have to do is rearrange my equation. So let me show you how we're going to do that. What I want to do is get the M by itself on that side. But right now, this pesky little volume is sitting there, and the volume is actually dividing the mass. So what I'm going to want to do is get rid of that volume. And here's how I do that. Whatever the volume is doing to the mass, if I could do the opposite of that, I would be able to cancel it out on that side. So if right now the volume is dividing the mass, if I multiply this side by the volume, then you're going to see that these volumes will cancel out. If they cancel out, then I'm left with M alone on that side. Just remember that because this is an equation, whatever I do to the right-hand side, I have to also do to the left-hand side. So now I've got a new version of the formula. Let me write that out again. I've got V times D equals M. And now because the M is alone, I can solve it. If it makes you more comfortable, feel free to rearrange the equation so that you can have M on the left. But it really doesn't matter. You can solve it even if it's alone on the right, as long as the M is alone, because M is my question mark. That's the one I'm trying to solve for. I'll take that formula. I've only got 2 marks so far. Now I want to get my third mark, so I'm going to substitute 8.4 grams per centimeter cubed multiplied by the volume. Just a reminder, if there is no symbol in between these letters, it means multiplication. So 100.8. You now have 3.5 marks out of 4. If you want 100%, you have to tell me what the unit's going to be for that mass. All right, let me show you how to figure that out. Normally, we've got it written as, you got grams sideways, right? Sideways slash, G slash centimeters cubed. That's the same thing as having a fraction on its side or writing a fraction on top of each other. Now hopefully you can see that a fraction on its side, 1 slash 2, is really just 1 divided by 2. So if I have grams slash centimeters cubed, what I really have is grams divided by centimeter cubed. Okay. And then, so that's what this is up here. Okay. And then I've got it being multiplied by centimeters cubed, right? That means that I'm going to be able to cancel out the units just like I'm able to cancel out the any numbers or anything like that that would be above that. So let's say I had 2 divided by 2, I just cancel that. If I have 4 divided by 2, I can cancel them out. I can simplify. So that's what I'm going to do. I'm going to say 1 above, 1 below, units cancel. And so I'm just left with grams. So then I know that my unit will be grams for that answer. You're also going to get to know that if you have grams, you know that that's a mass value. If you have centimeters cubed or milliliters, you're going to know that's a volume and so on. And density is always the mass divided by the volume unit. So you'll get used to it over time and it'll be pretty easy. It's probably pretty easy for some of you already. Let's do the third one together. So here we are. We need to find the volume. That's our question mark. So V equals question mark. We're using a wood block with a mass of 24, so there's my M, and a density of 0.9 grams per centimeter cubed. So looking for, we've been given density here. So we write it out. We got our V, our M is 24 grams. You have to make sure you're writing the units with these numbers. I want to know 24 of what? Is it a gram? Is it a kilogram? Is it a pound? What type of mass are you dealing with? And then the density is 0.9 grams per centimeter cubed. So now we take a look at that and we say, what version of the formula do we need? Well, I need the one where V is by itself. So I start off with the equation I have at the top. Now I'm going to need to get this volume alone up on this side. And the way that I do that is I multiply, I have to do a couple steps. I'm going to multiply both sides by V. Okay. When I do that, I can cancel the V on the right-hand side. So now what I've got is that same formula I used above. But I don't want M by itself, I want V by itself. So now what I'm going to have to do is get rid of the D. So I want D to go to the other side. So the way that I do that is I just divide both sides by D. Okay. Now we're going to see that the D's on the left cancel out. And now I'm left with the formula that I need. V equals M divided by D. You have options. You can learn how to rearrange these equations, which will help you with your math in high school. And you're going to have to learn how to do that anyway. You will always be given one version of the formula, and then you just have to figure out how to rearrange it to use it. Or you can memorize these things. I suggest that you learn one equation, one version of it, and learn how to move things around. It'll make your life so much simpler. But here we go. Let's go ahead and use this now. So I've got my volume, my mass, and my density. I'm going to do my substitution step because I want my third mark. 24 grams divided by 0.9 grams per centimeter cubed. I'm going to extend that line so it covers everything there. And then I just need to do the math, remembering that that line means divide. So you get 26.6 repeated forever, so we're just going to round that to 26.7. And then the question is what units is it going to be? You could guess right away, because this is volume, it's going to be a centimeter cubed unit. So that will be the answer. But I want to show you why that's the answer. This is this weird thing that we have to do with fractions. One of the rules for fractions that we can use. So let me show you. Right now we've got grams being divided. That's what that line means there. That means divided. Grams are being divided by grams per centimeter cubed. Now if this was just a regular fraction, let's say I had 4 being divided by a half. Okay. If you've got 4 divided in half, there's this weird kind of thing, divided by a half. You've got this weird rule that you have to do to divide by a fraction. And what we end up doing is it's called multiplying by the reciprocal. So we'd say that that is equal to 4 times 2 over 1. 2 over 1 is the reciprocal. So we multiply by the reciprocal. Okay, fancy math terms. So we're going to do the same thing for our weird little unit problem here that we have to do. So I'm going to say that this is then equal to, in the red here, grams times centimeter cubed divided by grams. All I did was flip it with the reciprocal. So now what I can do is cancel out those grams. Okay, and I'm left with centimeter cubed. It's a bit tricky. Much easier to just memorize the fact that you've got centimeters cubed is going to be your volume. Grams will be a mass unit. And then if you have a density, it'll be some kind of mass number divided by some kind of a volume number. These are the main 3 types that you'll see, because if you notice, we've got the very first question asked us to find density. So we used that version of the formula. Then we were asked to find mass. So we used that version of the formula. And then we were asked to find volume, so we used that version of the formula. So you've now seen the basics for all 3 versions of how we can find density. So now we're just going to apply it, and we're going to go one step further with this next question. So now we're being asked to find the density of the block. Okay, great. I know that that's going to be D equals a question mark. But then I'm given all this junk right here. Okay, so then I'm told that the mass is 1,134 grams, right? But what is this all about? If you can picture it, what we're being told is the dimensions of the block, right? We're being told that you've got a block that is 9 centimeters by 7 centimeters by 2 centimeters. We're being told the size of our block, right? So really what we're being told is the volume. Now, we have to take it one more step though, because we have to actually calculate the final volume. So we're going to be writing down, rather than the volume is equal to centimeters cubed value, we're going to have to calculate that volume, and that's what we'll do next. We're going to say the volume is equal to, and we're going to have to calculate this sucker. So instead of saying the volume is, we don't know what it is yet, we have to still calculate it. It's an unknown as well, but we do know that the length of the block, 9 centimeters, we know the width of the block is 7 centimeters, and then we know that the height of the block is 2 centimeters. So then we just have to remember our volume formulas. So if we've got length, width, and height, we just multiply those suckers together, and then I can find the volume. So I know the volume is equal to the length times the width times the height. Then I just substitute in 9 centimeters times 7 centimeters times 2 centimeters, and I do that calculation. We find out that when we multiply those 3 numbers together, we're going to get 126, and then because it's centimeters times centimeters times centimeters, we end up with centimeters cubed. So that's our volume calculated. But we haven't answered the original question. The original question is, what is the density? So we still need to go through and do that. So I'm going to get my density formula. Density is equal to m over v. And then I'm going to substitute in what I know. Now, originally I needed to put down what the mass was that I was given. I was given a mass value of 1134. So on the left-hand side, I'm going to add that in as well in my given section. And now I can substitute in what I know. So the mass volume and then the volume that I calculated. So we find out that 1134 divided by 126 is 9 grams per centimeter cubed. Okay? This type of a question, because it has those extra steps, is worth a few more marks. If you want to get your complete marks, you want to make sure that you've got your given. Okay? Must have your given section. In this case, though, because you have a new set of formulas that you need to have, you get a mark for the formula, a mark for the substitution, and a mark for that final answer there with units. And you get marks for this stuff as well. So you need to make sure that each of those stages are still there. You still have the formula, you still have the substitution step, and you have the solution with units. And you have to do that for every single time. And the reason we're doing that is we're trying to prove our answer. We don't want to just sort of make stuff up and hope for the best. We want to make sure that everybody knows that that 9 grams is the per centimeter cube, that everybody knows that the 9 grams per centimeter cubed is the density proven through the mathematical formulas that we've used. Okay, one more example and then I'll leave you guys to do your practice. So here in our final example, it's important that you read the whole question so you understand what kind of information you're being given. You need to know that we are being told the density right up front. And the density of copper is 8.7 grams per centimeter cubed. So that's an important piece of information. But it starts talking about this metallic object. So this is some unknown object that we don't know if it's copper or not. It's just a metal object. We know its volume and we know its mass, but we're being asked, is it made of copper? And you're probably thinking to yourself right now, well, it looks like we've got a D value, we've got a V value, and got an M value. What's there to solve? Well, we don't know if this metallic object is copper or not. It could be any type of metal. So we're going to have to solve for the density of this metallic object and then compare it to the density that we've been given. So we've been given 2 different densities when we're writing down our information here. We have the D for copper, and we can write that in little subscript letters down below to identify that this is the density of the copper information we've been given. And then we have the volume of the metallic object. So we have volume, I'm going to call it MO for metallic object. And that's equal to 90 centimeters cubed. And then we've got the mass of the MO, the metal object, 950 grams. And our question mark is, what's the density of this metal object? Density of the metal object is unknown. Once we have this density figured out, we can just compare it to the density of copper. If it's the same number, then yes, this metal object is made of copper. If it's a different number, then no, it's not copper. It's some other type of metal. Okay? So let's write out our formula and we'll get the rest of our marks here. So we can say that the D of Mo is equal to the mass of Mo, mass of the metallic object, divided by the volume of the metallic object. Substitute it in, 950 grams divided by 90 centimeters cubed. So you divide that out and you find out that that is 10.6 grams per centimeter cubed. Great, so the density of the metallic object is 10.6. Is the metallic object made of pure copper? With this type of a question, you're going to have a final statement as well. Notice we didn't bother to do final statements with the other questions, but this one requires it because the question is kind of designed a little bit differently. So then we would want to say then, therefore, get your 3 little therefore dots, therefore, the object is not copper, and our reason for that, it's since, and we can use a little math here, math language as well if we want, we can say that the density of the metallic object is not equal to the density of the copper. So this little equal sign here with the slash through it means not equal. And that's how we solve problems like that. So now what you need to do is go ahead and get this practice down here done. When you have finished this homework, make sure that you go online and you check the answers for that particular handout. You'll see it's called Calculating Density. So make sure you check your answers. You need to make sure that you have good format. If you were to mark it, would you give yourself 4 marks? Did you make sure that you had the given section? Did you make sure you had your formula that was correct? Did you make sure you had a substitution step? And did you make sure that you had that final answer with the units? Even if you're not 100% sure where to start when you first start reading the question, if you do what I did, where you just start laying out, okay, there's the density and you write that down, there's the mass and you write that down, there's the volume and you write that down. Even if you just start doing those little pieces, it might become very clear to you because you're going to know what you've been given. You may over time be able to figure out, oh, okay, that's what they want. That's what they've been trying to get me to find, okay? So just step by step, follow this format, and you're going to be just fine. That is officially the end of your lesson. Take care.